Hello, I'm Kurt Schelzig, and this is my proposal for funding for the research of the development of a wireless system of transmission of energy. Currently, wireless power uh, isn't really used that much. It's mainly used for charging small devices like phones and as a novelty. However, if we were able to develop a system of wireless transmission of energy which didn't require an arcing, that would allow for powering of things which cannot have onboard powering. One of the major examples of that existing right now is nanobots. But also things like electric cars may have a massive benefit to being able to be charged while in motion or just while interacting with the field. Additionally, it has the benefit of being a highly convenient methodology of charging. Simply walking near a podium and that charging your device would be just incredibly useful for people who are, say, in airports. And also, there's the benefit of inductive coupling, which I can get back to later. But basically, when you have a stray capacitor, you can also then couple that with a resonating inductor or a feedback resonant inductor, which would be able to draw power very effectively. But for some background, there are currently two main methods of wireless energy transmission. The first is resonance-based, which essentially requires that you have high inductive and capacitive coupling, and predominantly requires a high degree of a controlled environment, with very little changing in the area surrounding its capacitance. This is predominantly wireless transmission based on the inductor. In the other side, we have capacitive inductance, which requires that you basically charge a capacitor using the inductor, and the inductor tunes to the charged capacitance. The problems with the resonance are predominantly there's a low range, high input voltage, and low efficiency. They also require that you have a very stable capacitive field, which just isn't realistic when you're transferring energy through it. So instead, I advocate that we use capacitive wireless transmission of energy, uh, predominantly through using a Slayer exciter circuit. This is a type of Tesla coil which, instead of focusing on inductive tuning or capacitive tuning, focuses on the inductive tuning. It does this by charging up a high amount of parasitic capacitance in the air without discharging. This has the benefit of creating little to no arcs, and also generating a field of usable energy, which can easily be tapped into by anything which draws upon it. Essentially, the way it operates is you have energy which feeds through a primary into a secondary, which generates a magnetic field, and because of Lenz's laws counter to that, it generates an incredibly high voltage and an incredibly low current over a large amount of area. Basically what happens is the power feeds through the battery and then feeds into the primary, which then, as mentioned earlier, generates energy into the secondary. Then the battery also feeds to this resistor, which feeds into the opening side of the transistor. What this does is this causes this gate to open, which allows energy to flow through this primary and through the secondary, which causes energy to feed in through the secondary and up, which then closes to the which then closes to ground once it hits a negative value of 0.7 volts. And so what that does is that creates an oscillating amount of energy difference on the capacitive side. What this will create is this will create a field which never arcs, but also is able to create consistent voltages in the air surrounding it, which do not change with interference in the field. They can only just be drawn upon. So the reason why there's no arcs is because the impedance of the air the impedance of the circuit is greater than the resistance of the air. What that means is that the net resistance of the resistor here, the inductance of this coil right here, and this diode right here is net equal to the resistance of the range of this capacitive area. So basically that means that if we're able to get a higher voltage and a higher current into the secondary, it will be directly proportional to these resistors, which means that it will never be able to arc or will never be able to exceed the voltage which these require for breakdown. Here's proof that it operates as a parasitic capacitor. The video doesn't seem to want to work. But basically, it's me showing my previously functioning methodologies. You can see those in a link at the end of the presentation. And that brings us to my first measure of success, which is the range of this device. So as we're able to charge the air does have a breakdown voltage. So what we need to be able to do is we need to be able to charge the air at a range without exceeding this breakdown voltage. That can basically be done by determining methodologies in order to ensure that the capacitive coupling is optimal. The major way which this can be done is through this feedback right here. Because the secondary is able to communicate directly with the circuit, that means that there is a very high ease of communication between the two, so that way you can easily couple the impedance. Um, and so so most chargers right now can range about 6 feet. I've aimed for 2 to 3 feet, as that gives a range which can be useful, and competitive with some more common, like small range things, but isn't so far that it isn't realistic for my time frame. As far as the wireless transmission of energy goes, because the air serves as a capacitor in which a voltage difference occurs, we need to have a grounding in order to draw on it. So this is for my adapter. So for the adapter, you need to have a grounding which is able to draw upon the circuit. This can be done through several methodologies. You can have a cable which runs to ground. You can have a grounding plate, or you can have a counter-negative coil. All of these methodologies allow for you to draw on the field without arcing it in order to generate energy, and if the video above had worked, you would have been able to see that it's able to excite fields. As far as the circuit which I plan to use to draw from this thing goes, or from the Slayer exciter circuit goes, is I want to have a positive antenna which is able to interact with the field, which then feeds into a full bridge rectifier, which essentially takes the waveform from, I can draw it, which takes the waveform from a AC waveform and turns it into just the positive aspects of that waveform, which can then be fed into these capacitors right here, which then gives you a SAW waveform or a functional DC waveform. This is then fed into a buck regulator, which takes the voltage and steps it down to 5 volts at 1 amp. The idea behind this is that that is a common metric of success for these wireless transmission things, because that's able to power most computational circuits. For example, an Arduino is able to be powered off of that, and it's also able to do things like charge a phone. Then all that has to be applied to this is the load, which will be what we'll use to draw from the circuit. Again, as I mentioned earlier, full bridge rectifier runs through here and has those dips. And the buck regulator operates. The buck regulator operates by having this Zener diode right here, which then feeds to the inductor. The inductor is then coupled with the switching device, so that way they oscillate at the resonance frequency of this inductor and this capacitor. So basically, you have this feedback from the load, feeds into the switching device. For the switching device, I'll probably use a 2N2C2A. Which then oscillates between these two. And what that does is it limits the voltage and limits the current to a consistent value. And this brings me to my second measure of success. In order to be useful in its transmission of energy, it does have to be able to transmit this amount of power. So the vast majority of wireless energy is currently used for iPhones, so I plan to use it at, so I plan to be able to measure the success as being able to transfer 5 volts at 1000 milliamps, or 1 amp. What this allows me to do is it allows me to easily determine, 1, how far I'm able to transfer energy, and 2, to what degree I'm able to do that. And so the ratio between those two factors will be able to help me in determining what is best for the system. Here are my sources. In this, it includes 2 videos of my successful circuit designs, and that is all. Thank you.